to the new problem of dynamic programming, the minimum cost climbing stair LeetCode 746 number problem. So let's see what it tells in the question. You are given an integer cost, and cost of I is the cost of ith step on a staircase. So they're telling that we are given an integer array cost. So we are given an integer array cost, and where cost of I is the cost of ith step on a staircase. Once you pay the cost, you can climb one or two steps. You can either start from step with index 0 or 1. So here they told that we can either start from the index 0 or index 1. We can either start. Return the minimum cost to reach the top of the floor. So here they told us to find the minimum. This is the optimization technique. So we can apply here dynamic programming. Now this is cost, and that is the output 10, 15. And we always should look at the constraints because we must follow this. So 2 less than equals to cost dot length. That means it is always between 2 to 1000 the length is, and nothing more. 0 less than, the cost is between 0 and 999. So let's understand this, what they're telling in the question. Okay, first they're telling you are given an integer array. You are given an integer array cost. Integer array cost, where cost of I is the cost of ith step on a staircase. So let's assume there is a staircase like this. This is a staircase. So we are assuming that is a staircase. This looks quite big. Okay, so you are given an integer array cost. So we are given an integer array cost. So this is integer array. Let's assume this is integer array. We are given an integer array cost, and the name of this integer array is cost. We are given this integer array cost, where cost of I is the cost of ith step on a staircase. Let's suppose this is 0th step, this is 1st step, this is 2nd step, this is 3rd step, this is 4th step, this is 5th step, this is 6th, and this is 7th, so on. And here the index. Here the index of this array is 0, 1, 2, 3, 4. So if we represent here the array, the cost of 0, the cost of 0 is representing the cost to move from here, from here to here or here to here. This is, they are telling where cost of I is the cost of ith step on a staircase. So they're representing that index, that cost. You can either start from step with index 0 or step with index 1. So they told that we can either start with step with index. So we can either start from this stair or we can start from this stair. We can start from those two stairs. So right now we are having two opportunity where we can start. That means for that we don't need to pay any cost. So without cost, free of cost, we can either start from step 0 or step 1. This is one free, that without cost. Here we don't have to cost, so we can either start from this index or we can start from this index. We can start from these two positions without any cost. Return the minimum cost. We have to return the minimum cost to reach the top of the floor. So okay, that is the question, that we have to return the minimum cost to reach the floor. And let's say this is the floor, this is floor section. So suppose we are here, we are at this position. Now guess how we can reach this position. So if you got the clear idea from the question that they are telling either we can reach one step or we can reach two steps, and what is our motto? This is our motto: return the minimum cost. That means we always have to find the minimum cost. We always have to find this minimum cost. This is our core goal, to find the minimum cost. So here we can reach through only two ways, because they gave us two strategies. The first way that we can directly move from here to here, and this will cost us 1. The cost of this position, this has a cost, either we can reach from here, because they told us that we can also look, once you pay the cost you can either climb one or two steps. That means we can either climb one step we can either climb, or we can climb two steps. So we can climb from here also directly we can climb from here, and then we can climb from here. So that means we can even climb two step, one step or two step. Now observe, so suppose we are climbing from here, we are climbing from this position, so we have to pay the cost of this position, and the cost of this will be what? If that's our index of 7 array, so the cost would be of 7th position, the cost would be of 7th position. So we had to pay the cost of index 7, cost of index 7. Look, we had to pay that cost of index 7. Now guess, if we are at index 6, we had to pay the cost of that index. They are telling that once we pay the cost we can climb, so we have to pay the cost. So if we are at index 7, we have to pay the cost of 6. Okay, so this cost we have to pay, Okay, so that is the cost that we have to pay, the 6 and cost of 7. Now observe, our main goal is to minimize the problem, and now we have to check the total cost. Now we'll be checking for which case we have the total cost. So when we are paying, if we are selecting, suppose this one, suppose we selected this stair, we also have to check the minimum criteria, of this entire stairs, we have to check the minimum criteria, that which cost us minimum. So we'll be checking the minimum cost to reach from this one to this position. What was this cost internally? So we'll be adding this cost also, dp of let's say I minus 2, that represent the cost. And for this section we'll also check for that section. We will also be checking the cost, that to reach that section from the starting, what was the cost. And if we add that total cost, dp of I minus 1, so the cost from reaching from beginning this one to reach up to this one and this stair, then we're reaching at the goal, and from starting here to this one and up to 2. So among them, whatever will be the minimum, we will decide that one. We will be deciding that one as the minimum cost. So that is the programming that we can easily solve using dynamic programming. So I think you all got a clear idea how we can do it. So if I can make you understand in here also the program of each step. So first let's understand it in one by one in the code, and meanwhile I will make you understand. Okay, this is already the code. So that is already the coding section. So I'm just removing, and first now I'm making you understand with concept. First we'll be initializing, we'll be finding the number of stairs, and this number of stairs we can easily find from this cost. This number, the number of input values represent the number of length. So integer n equals to cost array dot length, length. So we got the number of stairs. Okay, now we saw the two cases, that from index 0 and from index 1 we can move, or we can start without paying, because this is stored in the question. You can start either from index 0 or 1 without paying. So we'll be writing that line. So before we write that line, first we will be initializing the dynamic programming array to store the minimum cost to reach each step. If you looked at the theory, look here, this was the cost, and the cost we got of all the path, the entire path that we got, because we stored the array, we stored that cost in the array, and that's why we will be For all the paths we will be creating an array like this. Integer dp, that is equals to new integer of n plus 1. And when we will be utilizing this array, so we will be creating an array, we will be creating a long array, and there will be keep increasing the cost of the stairs. We are drawing the stairs here. So if that is the stair, so the total cost to reach here will be storing it here. The total cost to reach here up to that length will be storing in this section. The total cost to reach up to that section, so we'll be storing that in here. So in that way we'll be keep storing the total cost. Okay, so we'll be writing that line, integer dp, that is equals to new integer of n plus 1, n plus 1. Okay, so we for storing the total cost from beginning created array, created dp array. Okay, now there is two places where we can move without paying any cost, and that is dp of 0 and dp of 1. For moving up to the first index, that is dp of 0, we don't have to pay any cost. So we will be initializing that cost as 0, and that is the base cost. So dp of 0 equals to 0. And also for 0th index and first index we don't pay any cost. So dp of 1, that is equals to 0, and these two are the base cases, because from here we start composing the program, and in any types of optimization situation where we can apply dynamic programming, we get that base case. Now we got this. Now we'll be starting from the next index. For integer I equals to 2, I less than equals to n, I plus plus. So we are starting, and it will run up to the entire length, the number of all the stairs. And for that, in here we'll be storing the total cost that I show you. So here we'll be storing dp of I, that will be equals to math.minimum, because we'll be storing the minimum. So what we'll be storing? The cost. So we'll be writing the cost like this, math.minimum. So the cost will be of in two cases, when we are traversing from one index and when we are traversing from two index. I'm showing you it in again diagram. Look, when we will just put this one, the cost of this index, that is if we are in this index, suppose we are in this index, so if that is the roof, so will be that cost and that cost. So this is n minus 1th index and this is n minus 2th index. So that cost we have to write. So we'll be writing that cost in generalized format. So math.minimum cost of I minus 1, comma cost of I minus 2. Look, that is the cost of individual stairs. Now we have to also put the cost of this one. This we just put the cost of individual stairs, this in stairs and this stairs. But we had also a cost if that was the entire stairs. So it also took us cost to move here. So that is the cost. That this is also having a cost. So this cost is represented by dp of I minus 1 and dp of I minus 2. So we also have to add, and among the minimum sum will give us the result. So we'll be putting that. So this is cost of I minus 1 plus dp of I minus 1 plus dp of I minus 2, dp of I minus 2. Okay, so that is the minimum, and now we'll be return dp of n, because that will provide us the solution of dp of n. So all correct. Let's submit it and see if we get any mistake. Time limit exceeded. I don't know why I got this error. Okay, so I thought and just optimize the code. So first, as we found out the number of steps stats, and then we found out the base cases that if that was n equals to 0, we are returning 0, and if there was n equals to 1, then we're returning the cost of actually not 1, we are returning the cost of 0. Whatever the cost of, we are returning the cost of 0. Now then we are initializing variable to store the minimum cost to reduce the last two steps. So integer previous 2 that represents the last two steps, it represents db of 2, the cost of up to 2, and integer previous one, this represent the cost up to I minus 1. So after that, this is in first and second, zeroth and first index. We start from I equals to 2, I less than equals to 10, and I plus plus, and then we just run this, the same thing, swapping that we have already done in Fibonacci. That type of swapping, just we find the math.minimum value and store it current, then previous one is updated and previous 2 is also updated in the similar way, and we just get the result. So let's try submitting it. I've already tried submitting once and it worked. So it worked, and this is the web program that we see. So time limit exited will also remove, because we have utilized program. So in this program we had to use the complexity of big of n. They actually didn't mention in constant, so whenever we write any program, that should be our core focus. So that was all that we decided. The code, that was almost everything same. In last portion we just updated the code. So okay, we'll be discussing about that next. Hope you got the concept.